Hi, my name is Ehsan Khan, and today I'm going to present you my research literature review analysis on brain-computer interface, also known as BCI, with respect to the control signal review. So let's start it. So what is a BCI? It is also known as BMI, which means like brain machine interface. It allows the machine to communicate with our brain neurons. Actually, it translates the brain neurological signals to the command for the system or any external devices. And there are so many researchers working on in this technology, and so many people in medical domain working on the neuromuscular pain or neuropathy. They are trying to cure these diseases using the BCI because it's allowed them to interact with the brain neuron signals. What is the scope of this paper? The scope of this paper is like identification and classification of brain signal, current implementation of BCI, and the challenges and the future research with respect to the BCI. So let's talk about the brain. So brain, our brain is divided into two parts, cerebral cortex and subcortical region. Cerebral cortex is responsible for thinking, and making movement, doing stuff. And subregion cortex is responsible for like a heart rate and lungs performance, kidney, and blood flow, all that stuff. And cerebral like a subregion goes under the cerebral cortex. As you can see in the diagram, there are other parts of the brain they are mentioned, but the upper layer is the part of cerebral cortex, and underneath of cerebral cortex there is a sub-region cortical, which is responsible for all the body internal workout. Now let's talk about the BCI classification. There are, as you can see in the BCI classification, we are going to discuss about dependent classification. Dependent classification, dependent is when it's when BCI is used to move things like games, wheelchairs, stuff like that. And there's another within the dependability, there is a dependent and independent. So dependent is used to move game and wheelchair, and independent, it helps those people which has the severe disability, like they couldn't do anything. Now the next is invasive BCI. Invasive BCI then categorized into three parts: invasive, semi-invasive, and non-invasive. So invasive, it is done through the like a neurosurgeon implants the electrodes or devices on the brain, and it can be done with the highly skilled neurosurgeon. And next is non-invasive. It is it records the signal without penetrating through the scalp. So it is a non-invasive. And semi-invasive, it is implanted underneath the skull. And the main purpose of all the classification and categorize of these devices is to get the brain information or brain signals. Now we are going to move to the synchronization BCI. So the synchronization BCI is divided into two parts: synchronous and asynchronous. Synchronous is like when a system, like when you went to the doctor or someone, and they plug you with like a system, and for a certain time period they receive the brain information. This process is called synchronous BCI. And asynchronous BCI is like they give you a device, or like you are free to use that device anytime or any moment whenever you like. And asynchronous is also called a self place, like person can use that asynchronous BCI at any moment. Now let's move to the next. It is like EEG. These are the like technologies and which we use as a BCI for to get the brain information. So EEG, it's a like it receive the electrical and activities by firing the neurons in the brain. And electrodes, it places the electrodes on the cortex. As you can see in the diagram, the black spots are like the middle line, and they use electrodes on that middle line, so like they can receive the brain information. As you and there are like some issues with this technology, like it cannot be fit for all the other stuff, like for example, it cannot generate the brain imaging location of the tumor or the injuries, or it doesn't generate the brain cross section image as well. Let's move to the another one. It is called electro ECOG, electrocardiography. So it gets the information by through the invasive process. So as I described the invasive process, like a surgeon has to plant the electrodes in your brain, and then it will start receiving the information and all that stuff. And as it they would be like it's a like first of all, like you have to go through a surgery to for this device to be implemented in your brain. So it's a like a demerit in it, it's a negative point in it. Mag. So mag, yeah, it's uses like quantum physics electrodes, which is called square, and it is used for getting the complete image of the brain. And it is best use like it is recommended to use for detecting the epilepsy, or like people who got the brain tumor. So it this BCI is a really good one for those scenarios. The negative point about a mag is like the hardware equipment is super expensive, like an ordinary people cannot afford it. And it's going to be like a implement in your brain. So um, it is like a negative point as well. So now my next point is pet and aspect. They join both of them together. So PET or aspect, they both use for like getting the 3D imaging of the brain by using the gamma rays on the brain. And PET is more expensive than aspect. fMRI. So fMRI is non-invasive. Non-invasive means like it didn't need to penetrate through your scalp. So that's like a good point in this technology. And it gets a reading through the like a blood flow and the oxygen level variation in the brain, so you can get that information. So, but still it is not preferred by the researchers because of the temporal resolution is poor, and it gives the information about the temporal dynamics for their response. So that's why like researchers don't recommend it using it in the neural computing or neural sciences. Next topic, next more topic is FNRI. So it measures the values in the form of light reflections, like in the brain, but still, this one is also not recommended by the researchers, as you can see, like low temporal results. This is the like a chart which is like mentioned in the paper as well, and in the report as well. So some of the devices like are portable. There's like a like EEG, ECOG. These are portable, but the uh, NFIR. But all the others are not portable. Like you have to like hooked up with the device, and then can do the then they can do the testing on you, or do the stuff like do the research on your brain. Okay, now we are moving to the brain signal analysis. So there are like 5 types of brain signal, like a delta signal, which is like slowest wavelength signal, and it generates when you are in deep sleep or you are in the wake up state. And the theta wave is generated when you are in the idling state or creative inspiring unconscious mental drowsiness or deep medication, like you are when you are like when you are feeling down, then your brain is generating the theta signal. Alpha signal, it is generated like when you are going to move something like some muscle, then it generates. Beta wave is a wave like which is generated when you are thinking, alert or active, like when you are like getting a strategy to get out of the situation, or you are trying to solve a problem, or you are like being active for a some time period. So your brain at that moment your brain generates a beta wave. And gamma wave, it's a like a memory wave, like it recognize it's a sorry memory signal, like it generated when you recognize some sound, something, some sensation. So that time that wave generated, like sometime you feel like when you say like, oh, I think I see that person somewhere. At that moment, like your brain generates a gamma rays, which realize like that information is stored somewhere in your brain database, but your brain is not getting it right now. Now let's talk about the mental control signals, which is the like a main topic of this paper. So there are like a mental signal classification, which is divided into like evoke, spontaneous, and hybrid. So let's talk about the evoke signal. Evoke, they are like unconscious signal, and within the evoke, there is a like a evoke signal is also called EVP, and within the evoke signal there is SSEP. This signal generated when user receive a stimuli by image, sound, or vibration. And within there is another category of evoke signal that is called P300, and it got generated when subject receive a series of simulations, like a stimuli. So at that, after that, like then this signal generates. Mhm. Then there is a spontaneous signal. This signal generates by the external simulation. And within the spontaneous signal there is like a motor and sensory motor rhythm and non-motor cognitive task and SCP. So motor and sensory rhythms are like when you are going to move your muscle with bone, like running, walking, doing some stuff which involve like rotating your body or like your arms, something. SCP, it is a like actually a EEG signal which is generated by the cortex. Non-motor signal, it's uh, it's a signal generated when you are imagining, thinking, or calculating something. And the last one is a hybrid. It's a like a combined signal used to control BCI. Actually, we use a hybrid signal to control, use as a BCI input. It combines the multiple signal, like it joins the SSEP and SCP, or it joins the P300 or motor signals to use as a like a input for the BCI to perform some specific task. Okay, now we are going to talk about the BCI technology with respect to the software and the hardware. So BCI technology mainly use electrodes, or in this paper they use work on the electrode, but there are some BCI technologies which use the gamma receivers, just like aspect FRM aspect. They use the gamma rays, or FNIR, which use the color reflection. But in this paper we are going to target the electrodes. So electrodes are as I have discussed, like it is used in the EEG or ECOG to get the information from the brain. And there's the like a hardware, then we have the like a system which is hooked up with it, which receives the information from the electrodes and put it on the software. And there are so many software in the market which you use for BCI signal calculation, but our researcher use the following tools like BCI 2000, OpenVibe, 2B, BCI Lab, BCI plus plus, XBCI, BF plus plus, PyF, Py, PyFF. It's a, like a Python tool, and OpenBCI. OpenBCI is an open source and the free tool, so you can use it by yourself as well. It's a free to download as well. So you just gonna need to like deploy it on the machine, and you can use it, or you can just have the like info database of the signal, or like a data set of the signal, and apply that data set of the signal on like use a open BCI on that tool, and you can generate the results. So now I'm going to talk about the BCI challenges. What challenges in current market or current time period which we are facing. As we know that a BCI is a neurological technology, like which interacts with the neurons, and our brain is one of the most complex challenges that we have ever faced. Nobody couldn't understand the complete understanding and complete functionalities of the brain, because every brain is different, and we couldn't design the like a single modularity for the brain. So the first point is the BCI standards, and because of that complexity, our brain is super complex, so we couldn't create any standards for the BCI. And the next challenge, we are like participants and stable classification. It means like before user is going to use the BCI device, they need the specific training to use the BCI devices in order to generate the specific results or specific signal which can be studied. Electrophysiological issues. So electrophysiological issues is like sometimes electrodes did not get the correct reading, and it is then subcategorized into two parts: non-linear EEG, like get multiple stimulate at the time, like your readings can be disturbed when the user get multiple simulation at a time, so it interface interact with your results. And second one is non-stationary in EEG. When your brain generates the internal signal, it is also interfere with your results, and you cannot get the exact information what you are looking for. Then information transfer rate, ITR. So there are so many, we have like categorized some of the signals from the brain, but there are so many signals which are being generated from the brain, which is which we haven't categorized them, and we need a better machine learning algorithm, better artificial intelligence algorithm to resolve these issues. And the results which we get, these results has like a signal to noise, a very high signal to voice ratio, which alters the results. Number of classes, as I mentioned before, there are so many signals which we receive during the test, and which we haven't categorized them, classified them. So it is still if we are going to classify all of those signals, it is going to be a very high number of classes. And the targeted detection time. So as I mentioned before, we gonna need a better machine learning algorithm for the classification of those signals. They have tried multiple classifications, but they just identified 5 or 6 signals which are being generated from the brain. Okay. And now I'm going to talk about the sensor issues. Sometimes electrodes create generate some error because of hardware malfunctioning, or sometimes electrodes are not placed correctly. So those electrodes generate incorrect reports or incorrect information regarding the brain's signal processing. Real life application. So right now BCI equipment is very expensive, and it cannot be used in the real time application or real life application, just like a Fitbit or a phone, like you just wear it and it start generated results. No, you cannot do that. There's a one more big issue with the ethical and the security. It's about government rules, all the BCI equipment has to align with the government policy, government rules. And there's a one more complication with the security concern. It's hacking. We are still developing that technology, but there's a crack for everything. And if that technology got misused or got used for the hacking purposes, it could be a really big disaster. And now I'm going what would be the future direction for the BCI? What would we are going to discuss? In which direction we are going with BCI? So the future of BCI, user concrete application. It means we need a user requirement, and we need to generate the results with respect to the user expectation. User expectation means like user is going to get want to result, like how many signals the user is getting when he's thinking. So in this way, user knows like is the user brain is going to generate the um, alpha sorry SSEP signal or P300 or um, oh, I'm sorry, I got so yeah, thinking signal or any stuff like that, or like a rotately, like for example, if user feel numb in their hand or legs, so at what time these signals are being generated. And another thing which is on which the our scientists are working on, it is smart electrodes. So it is possible, like when we classified all the signals in the brain, so we might be able to design the electrodes more smart, and they can receive data more correctly, and they can classify the data more efficiently. Another thing is user confidence. It's a, like a user confidence, like still we are we are doing our best to get more and more result, but right now BCI technology is used for like in neuro neurological disorder or neurosurgeon, consultants, but it is right now it is like boundaried with the like a medical usage. It should be like in the future, if we think about the future prospect, like it should be used as a like a Fitbit, so user can track their mental abilities, what activities are increasing their thinking or like a smartness in their brain, stuff like that. You beyond user application, just like I mentioned before, like it should be like for everyone, not just for the like people who are facing neurological disorder, but it should be for everyone. Next is like we have seen in the like movies or dramas like cloud BCI, like when you have people use their brain to operate things. Just imagine like if we like use a helmet and we control everything without touching anything, like BCI for IoTs. Like if we want to just turn the light off, we think that oh, and the light just turned off. If we want to like go to the work, we just think okay, and our vehicle directed us to the work. And the last point is BCI in a box. So BCI in a box, it means like a BCI should be very portable, so it could be used and should be very cheap. It could be used by everyone. So that's the like a future we are looking in the BCI. And that's my conclusion regarding the BCI is a very potential and very important domain with respect to the science, technology, and in advancement of human. So we can still it's like in the beginning, like we are in the like we can say like it's in the beginning phase, but we are like progressing slowly in this domain because of the complexity of the brain. But when we crack the secret code of the brain, then we will find all the hidden question in the universe, and we will find all the answers in the universe. So thank you very much for listening to me.